Good morning, Arundel class. Welcome to Tuesday's maths lesson. This one is all about drawing line graphs. Yesterday we looked at how we can interpret them. Today it's going to be about actually drawing them as well. Now yesterday when we looked at the scales, especially on the y-axis, we saw that they were going up in different stages, and that's something that we might need to look at today as well. So here are some examples of some stages. You can see here on this line here, there are some different steps, which we call increments, and we're reaching a target 20. And there's a halfway point of 10. And there are 1, 2, 3, 4, 5 steps to reach that 10. 1, 2, 3, 4, 5, another 5 steps to reach 20. Now, if there are 5 steps to reach 10, I think these must be going up in twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Now the second one here is going from 0 to 200 with a step of 100 in the middle as well. And there are 1, 2, 3, 4, 5 steps to get from 0 to 100. Well, using my place value knowledge, I know that 100 is 10 times bigger than the 10. So if these were going in twos, these ones must be going in 20. 0, 20, 40, 60, 80, 100. 120, 140, 160, 180, 200. Let's have a look at the next one here. It's going from 0 to 400 with 200 in the middle, and still there are 5 steps in between. Well, that 5 steps to get to 200 from 0 to 200 divided by 5. If I'm not sure, I know that 20 divided by 5 is 4. So 200 divided by 5 must be 40. 40, 80, 120, 160, 200, 240, 280, 320, 360, 400. But what about this bottom one here, where we've got 0, 1, 2? Again, there are 5 steps in between each of the numbers shown. Well, I can still use my place value knowledge. Go back to my first one here. These were going in twos, 2, 4, 6, 8, 10. 1 is 10 times less than 10. So I'm going to divide those 2, 4, 6, and 8 by 10. 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 2. And there we are. There we can see those steps shown. Here, on this graph here, we've got some bits missing. Here, we've got a table on this side, showing the months of the year and the sightings of orcas or killer whales shown in Scotland's coast in 2017. The graph has got the title. Its axes are labelled, January, February, all the way to October, and the number of sightings are shown. And we can see this one is going up in twos. So someone has started to put the data on the table. Someone has started to put the data into the graph as well. But there are some bits missing. This one, for example, here, January, February, March. So this must be March's data here, and it's saying it's at 10. Well, this one seems to be done, doesn't it? March, if I follow up, there, 10 is shown. The next one's 15. Well, the next month is April, isn't it? So if I'm going to go along to April, I'm going to read up and I'm going to stop where 15 is. And I know they're going up in twos. So I've reached 12, 14, or 16 is too much. So 15 must be in the middle. May is shown as 14. So I'd go to May and I'd plot it there, on that line there. And if I was to continue doing this and I could join the dots and I could complete the table, I would end up with a graph and a table looking like that. In these graphs here, they're comparing the temperatures in Paris, in France, and Sydney in Australia. Now, all the data has been given from January to December, from 0 to 30, but there are some bits missing. There's no title, is there, in each of them? There's no axes labelled either. The y-axis hasn't been labelled. The x-axis hasn't been labelled either. We'll have to work out what's missing. Can you work out what is missing? Well, hopefully you saw that these are the labels that we'd need to put in. The temperature, the month, and the title to show what the data is all about, to show what the graph is about. Here we've got another table, but this time we haven't got any of the data or the title shown. I wonder what the title would be. The table shows how many cups of tea were consumed in an office for a week. Well, I think there's a bit of a clue there, isn't there? So the title would be about the number of cups of tea drunk in a week. Here we've got, obviously, the days of the week, and here we've got the number of cups of tea drunk. We'll be able to carefully plot that data into the graph, and it would look something like this. I wonder why. You could think of a reason why it drops so quickly over the weekend. I wonder why not many drinks are drank on a Saturday, or even none on a Sunday. Uh-oh, someone's made a bit of a mess here. Someone's drawn a line graph here showing the distance a car has travelled in 5 hours. And it's got the number of minutes here going up, half an hour, 1 hour, 90 minutes, an hour and a half, 2 hours, and so on and so on. But we can't quite see where this line goes. It does seem to be going in a straight line, doesn't it? So we've got to find, if the graph continued in the same way, how many kilometres would have been travelled after 270 minutes. Well, if we were to continue along here, it's going to be somewhere around that point there, I think. And that, to me, looks like it's halfway between 200 and 250. Let's check once more. Continue the line up to about 270 there. Yes, I think it would be 225 kilometres. This line graph here shows the temperature over 12 hours. Here we've got the hours at the bottom. We've got the title, temperature over 12 hours, and we've got that y-axis labelled here, the temperature, again going in 2s on this one. What's happening between the 4th and the 12th hour? And can you explain what's happening? Have a look. Find the 4th hour and the 12th hour. What's happening? Why do you think that's the case? What reason might you come up with? Well, we can see it's dropping, can't we? And it might be because it's night time. And so therefore the temperature drops. It could be something as well. It's not time specific. It's not 1 o'clock, 2 o'clock, 3 o'clock. It might just be the temperature drops during an afternoon or during the morning. It might suddenly get colder one day. But I expect more than likely it's going to be because of the night time where the sunshine's gone down and it's getting colder. This young man here, Lucas, is wanting to create a line graph representing the population of 4 different countries over 3 years. He says, I will use intervals of 1,000 for the population axis. Well, is this going to work on his line graph? So the population axis, if we're thinking about it, isn't going to be the x-axis. It's the one that's going to change, that y-axis here. And I'm not sure that 1,000 is going to be enough. Thinking about populations, we normally measure populations of countries in millions, and I don't think thousands are going to be enough. It's not going to work because populations of countries are likely to be represented in millions, not thousands. And if a million is 1,000 thousands and the population is, say, 5, 6, 7 million, that's going to be a very, very, very tall graph, isn't it? So hopefully you've had a chance to listen carefully to that presentation so you can have a go at the questions. Once again, there are 3 challenges. What chili 1, 2 chilies, 3 chilies. They're all on the same sheet like they were yesterday, but you can choose to do either questions 1 to 3, 4 to 6, or 7 to 9. The answers will be there, so you'll be able to check them as well. Don't forget to signpost your learning so you know, so we can see which parts you've been doing as well. If you need to go back to the video, you can watch bits. There's also just a copy of the PowerPoint on Google Classroom for you to use as well if you need to. Good luck with it, and we look forward to see what you've been up to. Bye-bye.